CERN's latest shocking discovery, inside the shadow of Geneva under the world's surface lies a wonder of human resourcefulness and a potential harbinger of annihilation: the enormous Hadron Collider, LHC. This machine is an uncommon device for researchers, empowering them to study subatomic particles and uncover the secret of the God particle, the Higgs boson. Famous physicist Brian Cox has made a chilling declaration that has stirred awe and alarm throughout the scientific and religious communities, proposing that something significant has been found at CERN with implications beyond our current understanding. Before digging into the ramifications of Cox's assertion, it is fundamental to understand how the Large Hadron Collider works. Built by CERN, the LHC is a 17-mile ring of superconducting magnets and the world's most powerful particle accelerator. It stands as a zenith of human accomplishment, capable of reproducing the conditions of the universe's creation. This Titan design allows us to unlock the secrets of the universe, uncovering something real and potentially disturbing. CERN, established in 1954, is one of the world's most famous research institutions, containing 23 member states and an immense range of specialists. The LHC is CERN's focal project, but it is only one piece of a broad network of accelerators and detectors that explore the subatomic world. The LHC accelerates protons to almost the speed of light, recreating the energy of the universe at the time of the Big Bang. The subsequent impacts generate temperatures millions of times hotter than the Sun's core, with a complex arrangement of magnets directing the protons on their journey, while advanced cooling systems maintain the magnets at temperatures colder than space. The LHC's design is an engineering marvel, working deep underground and protected from cosmic radiation. The entire ring is cooled to a temperature colder than the vacuum of space, which is crucial for the superconducting magnets to function. Collisions occur at 4 points along the accelerator ring, each corresponding to one of the 4 main particle detectors: ATLAS, CMS ALICE, and LHCb. These detectors capture the aftermath of collisions, allowing researchers to sift through the debris in search of the elusive Higgs boson, a particle key to our understanding of the universe's structure. The power and risk of the LHC. The LHC is not only a scientific instrument, but a testament to human creativity and aspiration. It represents our quest for knowledge and our desire to understand the fundamental forces shaping our universe. However, as we push the boundaries of our understanding, we must also consider the moral and existential questions that arise. What are the dangers of exploring the unknown? Could our quest for dominance inadvertently unleash forces beyond our control? What's happening at CERN right now, within the hallowed halls of CERN, where the frontier of human knowledge is continually expanding? A revelation has emerged that has sent shivers down the spines of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a respected voice in particle physics, recently made a statement that has both amazed and frightened the scientific community. The goal of CERN's Large Hadron Collider is to recreate a miniature version of the Big Bang, the event that birthed our universe. Cox also highlighted the potential outcomes of this goal, noting the LHC's remarkable ability to create new phenomena, including its potential to reveal the Higgs boson and study dark matter, a substance that constitutes a significant portion of the universe. The possibility of recreating a mini Big Bang is not just a theoretical concept, it is a tangible reality within the LHC. The conditions inside the collider mimic those that existed at the universe's inception, allowing scientists to observe the birth of existence itself. However, with such power comes great responsibility and potential risk. Consider the scenario where something goes disastrously wrong. In 1978, Russian physicist Anatoly Bugorsky experienced an accident at the Institute for High-Energy Physics in Russia, where a malfunction caused his head to intersect with a proton beam, resulting in severe injuries. Despite this, Bugorsky survived and continued his work, highlighting the immense power and potential risks of particle accelerators. The danger associated with a particle accelerator like the LHC is not to be trifled with. The potential for unforeseen reactions and the manipulation of the very fabric of reality are genuine concerns voiced by some in the scientific community. One of the most significant fears surrounding the LHC's experiments is the possibility of creating miniature black holes, regions of spacetime with such strong gravitational pull that not even light can escape. If the LHC were to produce such an entity, even on a small scale, it might potentially consume the Earth from within. However, scientists at CERN have assured the public that any black holes created would evaporate almost immediately. Brian Cox explains that understanding how the LHC could produce a black hole involves the fundamental mechanics of particle accelerators. When protons are smashed together at near light speeds, the energy is so intense that it could warp the fabric of spacetime itself. Imagine a trampoline stretched tight with a heavy weight dropped onto it. The surface would warp, and if the weight were sufficient, it could create a hole. This analogy illustrates the LHC's potential to create a gravitational anomaly. This intriguing yet alarming possibility has even caught the attention of prominent physicists like the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson might become unstable at extremely high energy levels, potentially causing a catastrophic vacuum decay, a vast event that could destroy the universe. Respected cosmologist Sir Martin Rees has also expressed concerns about particle accelerator experiments, including those at CERN. In his book Our Final Century, he revisits the potential risks of collider experiments, including the formation of vacuum instability. This instability could hypothetically trigger a phase transition that would ripple through spacetime, causing a catastrophe of unimaginable proportions. While these scenarios remain highly speculative, even a slight possibility warrants serious consideration. The stakes are incredibly high and the margin for error is razor thin. The experts at CERN have meticulously assessed the potential risks associated with their experiments and implemented numerous safety protocols to mitigate any potential dangers. However, scientific exploration inherently involves a level of uncertainty, especially when venturing into uncharted territory. The pursuit of knowledge has always been accompanied by risks, but it is precisely this willingness to push boundaries that has driven human progress. The LHC represents the culmination of decades of scientific advancement and international collaboration. Yet beneath its impressive exterior lies a domain of profound scientific inquiry filled with potential dangers and ethical considerations. The collider's primary goal of unraveling the mysteries of particle physics has led to remarkable discoveries, including the elusive Higgs boson. However, the immense energies generated within its confines also raise concerns about the potentially disastrous consequences of such endeavors. While extensive safety measures are in place to mitigate risks, the possibility of catastrophic events, such as the creation of microscopic black holes or other unforeseen anomalies, cannot be entirely ruled out. As researchers continue to push the boundaries of our understanding, it is crucial to approach these investigations with a keen awareness of the potential outcomes and a commitment to transparency and public discourse. The LHC, with its unparalleled capabilities and potential for groundbreaking discoveries, stands as a testament to human ingenuity and the relentless pursuit of understanding the fundamental laws of the universe. However, beneath its awe-inspiring exterior lies a realm of significant scientific inquiry replete with potential risks and ethical considerations. One of the most anticipated goals of the LHC is to uncover the secrets of dark matter, a mysterious substance thought to make up roughly 27% of the universe's mass. Dark matter doesn't emit light or energy and is invisible to current detection methods. Its existence is inferred only through gravitational effects on visible matter such as galaxies and galaxy clusters. If the LHC can successfully produce dark matter particles in a controlled environment, it would be a landmark achievement. Scientists would finally have direct evidence of this elusive substance, potentially unlocking one of the greatest mysteries in modern cosmology. However, even this possibility isn't without concern. Creating a dark matter particle in a lab is not just a scientific milestone, it's a bold step into unknown territory. We may not fully understand the implications of interacting with such fundamental components of the cosmos, and the possibility of unintended consequences cannot be dismissed entirely. Another area of groundbreaking research at the LHC is antimatter, the mirror opposite of ordinary matter. When a particle of matter meets its antimatter counterpart, they annihilate each other in a burst of energy. According to the prevailing Big Bang theories, matter and antimatter should have been created in equal amounts. But the observable universe is overwhelmingly composed of matter, with antimatter virtually absent. Why the imbalance? This is one of the deepest mysteries in physics. If the LHC can help unravel why the universe favors matter, we might come closer to understanding the very conditions that made life possible. However, the annihilation of matter and antimatter also raises theoretical concerns. What if in an uncontrolled setting we were to produce more antimatter than anticipated? While safety protocols are stringent, the high energies involved bring the question of containment and control to the forefront. The LHC's experiments don't just explore the large-scale structure of the universe, they dive into the quantum realm, probing the tiniest building blocks of reality: quarks, gluons, and other elementary particles. Quantum mechanics, which governs the behavior of these particles, remains one of the most perplexing areas of science. It defies our everyday understanding of cause and effect, suggesting that particles can exist in multiple states at once and influence each other instantaneously across distances. One theoretical risk raised by some physicists is the formation of strangelets, hypothetical particles that could convert ordinary matter into strange matter, potentially destabilizing the atomic structure of the Earth. Though highly speculative, the notion underscores how little we truly know about the consequences of manipulating quantum scale forces.